When you pitch a standard camping shelter, it's easy to assume the vertical pole is doing all the work. It isn't. A tent pole actually cannot hold up a structure on its own. When wind hits a nylon tent, the fabric stretches, spreading lateral load across the panel instead of concentrating on the strut. By pegging the fly, you tension the fabric into a preloaded spring. This locks the pole and prevents it from wandering. The fabric acts as an active structural member, performing a hidden job that remains invisible to the naked eye. Imagine a designer decides to upgrade this material to Dyneema composite fabric to save weight. Dyneema is a film with unidirectional fibers bonded between layers. Structurally, it is incapable of stretching. Because it cannot stretch, the fabric can no longer deform to redistribute wind loads or act as a stabilizing spring for the pole. When a material cannot perform these hidden secondary jobs, it ceases to be structural and becomes a skin. Any structural work stripped away from a material must immediately migrate into the object's geometry. The Durston X-Dome Pro 1 Plus solves this by using a specific geometric layout to compensate for Dyneema's rigidity. The two trekking poles are set at angled, opposing orientations. They form a rigid brace that supports sidewalls against lateral wind, regardless of the fabric. Without a flexible fabric to lean on, a standard vertical compression column would simply buckle. The structural workload didn't vanish. It physically migrated from the fabric into the geometric framework. This law also governs consumer electronics. The SYITRN RM1 CD player features a completely transparent acrylic shell. For this specific design, the transparent shell lacks the necessary rigidity to act as a load-bearing structure for the internal mechanisms. This forces the structural load path to relocate away from the shell and move out to 4 precision metal corner pillars. We see the same logic in high-performance automotive design with the Gordon Murray Special Vehicles S1. The design team removed the external rear wing, the front splitter, and the deep side skirts. The task of generating downforce migrated to the internal bodywork surface itself. Even decoration moves. The Hublot Big Bang Sapphire uses a colorless case, forcing the coloring job to migrate inward onto the skeletal movement bridges. Across all physical design, changing a material forces the invisible work to migrate to a different component. Components quietly perform a long list of secondary jobs: tension, damping, alignment, sealing, and wayfinding. These secondary jobs are almost never written down in official requirement briefs. This is the Cadillac V-Series.R, a purpose-built racing machine. The Cadillac V1 concept inherits its bodywork directly from this car, and those racing proportions dictate the concept's internal architecture. This racing inheritance forces a functional migration in the cabin. The interior is dimensioned entirely around a single custom seat and a helmet shelf, abandoning the traditional passenger requirement. If a designer fails to identify these unstated jobs before swapping a part, the physical geometry will inevitably expose the failure. Design decisions are inexpensive during the concept phase, but they become brutal once manufacturing tooling begins. Architects must identify every secondary job a part performs, from tension to alignment, long before the hardware hits the factory floor. To master consistency in your generative AI pipelines and prevent design drift, read the Depix Technologies white paper.